Welcome back to the updated beginner's crash course for FreeCAD 1.1 and above. In this lesson, we're diving into how to create a basic assembly and sub-assemblies using FreeCAD's Assembly Workbench. We'll continue from the previous beginner's course where we modelled 3 parts, 2 bracket variants and a base plate. Now it's time to bring those parts together into a working assembly. We'll cover subjects such as building a sub-assembly, combining sub-assemblies into a full assembly, understanding rigid versus non-rigid assemblies, use basic joints, and work with advanced offsets. If you haven't already completed the previous modelling course, you can either follow that first or download the finished project files and jump straight into the tutorial. I've linked the earlier videos and project files in the description below. So let's get started learning assemblies in FreeCAD 1.1. If you're enjoying this channel and you want to support what I do, I have a Patreon page. You can pledge support only or choose a selected tier that includes early access to videos, downloadable written PDFs of tutorials, and some extra bonus content. If that sounds good to you, I left a link on screen and also in the description of these videos. So in FreeCAD, let's start a new document. FreeCAD's integrated Assembly Workbench can be accessed from the drop-down and selecting Assembly. Once in the workbench, you'll notice that most of the icons are grayed. Let's click on the Create New Assembly icon. The icons start to become active now we have a new assembly. Within you see the Assemblies container in the tree view. We have the Origin, which defines the assembly's orientation, and the Joints folder, where constraints between parts are managed. The joints which appear up in the toolbar are used to define how components relate and move relative to one another. To start adding our parts to the assembly, use the Insert component or the component from the task panel. At the moment we don't have any components loaded, so let's open a file and select our base part. And click Open. The loaded component body will appear in the list. We can open the bracket file in the same way. When we open the bracket file, you'll notice that there's 2 bodies within. So each body is a part, and a part is treated as a component in an assembly. We can click to add a component to our assembly, but it's going to ask us to save it first. Let's save our document and call it Bracket Assembly. Our base component has been added to the 3D view, and we also see it in the tree view. Now normally when adding the first part, it'll ask you if you want to ground the part or not. This is a grounding constraint. There has to be at least one grounded component in your assembly. If you don't see this message, then we can ground the part by this constraint. If a part is grounded, and we'll just OK the tasks, select the part and ground it, then it can't be moved. We'll ground this part for the time being. The grounded will appear in the joints. So we have a grounded joint here. Let's go back to the Insert component, or select it from the toolbar. When we add components, if we click say on another base, we see that one is inserted by the side of it, and it can be transformed with the transform widget. If I want to remove it, we right click to remove it. If a part is added and we transform it and we click off, then we can select it again and select once more and the transform appears. The grounded part, as you can see, we can't actually select it to transform. I don't want 2 bases, so let's right click to remove it and click off to get rid of the widget. Let's OK this for now. We have our first component in assembly. Note the assembly is in bold. Same as the part design. If I right click, we can see it's active. And if I double click, we can toggle whether it's active or not. When working in assembly, adding joints and moving parts under constraint, the assembly must be active. It's important to remember that the inserted components in the assembly are links and not copies. If we expand the imported base component and double click a feature, let's say the mirror, we've jumped to the part design. If we look in the base part, we can see we have a base, and inside the mirror is selected. So if I change this, let's say we want to mirror along a different plane. Let's pick the XY plane and hit OK. The base part has been updated, and in our assembly, this is reflected in the base link. I'm going to select Undo. So we have to be careful when manipulating these objects. Also, we must make sure if we've performed such an operation, i.e. double clicking on the mirror, the assembly has become inactive. We have to double click on the assembly to activate it again. It's especially important to remember this when moving objects. A common assumption will be to click, say, on the base part and right click and transform. Therefore we get the standard transform tools. But this is not transforming the assembly. As you can see, if I move this, it's moving something else, which should be a red flag. Let's cancel that and make sure the assembly is active. If I wanted to move this part, first of all, we have the grounded joint, which I'll select the part. We just toggle grounded. That removes that joint. Because the part is selected, I can select it again and get the assembly widget to transform. If it's not selected, I have to select once, then twice, then I can transform this. Don't use the right click transform because this is transforming something else. Let's cancel that. It's also important to remember that this is a link when we get to deleting components, which we'll go through shortly. Make sure the assembly is active. Let's add another component. Let's use the component icon. This time we'll add a bracket. The transform widget has appeared, but I can also drag this because it's not grounded. Let's drag this over here. We've got one bracket inserted. That's fine. Let's hit OK. Let's make sure the base component is grounded. We've got the lock icon. Now we can drag our bracket into a position ready for joints. Again, it's the same for transform. Click once, then again, and we get the transform widget. So we can move it into position. Joints are the foundation of constraining parts together. The joints can be selected from the task pane or from the toolbar. There are two broad types of joints, those that allow motion and those that don't. We've already been introduced to the grounded joint. We're now going to be introduced to the fixed joint. This is the most basic of joints, and when creating assemblies that don't need motion, you'll be primarily using this one. Make sure nothing's selected and select the joint. In the task pane, we see the type of joint has been selected and we have a list underneath. I'm going to constrain the bracket to the base. You notice as we move over edges and faces that underneath the mouse pointer is a coordinate system. The red, green and blue arrow indicates the exact position and orientation where the joint will be attached. The blue Z-axis is especially important, as it usually defines the primary direction of movement or rotation if the joint allows it. So we're going to fix this bracket. If this isn't in position, then just click and drag it out the way so we can get to it. And as you can see, I can select an edge or the inside face. Let's select the edge. On the right, we have the bracket edge appear in the list. To remove it, we select the edge again, or we can right click on it and remove it from the list. Once selected, let's select another edge. Now I'm going to select another circle. Now it's going to be easy to constrain to this one. You can see how the blue axis lines up. Let's instead pick this one. Just orientate our 3D view and we click the circle. The joint is applied. To the right we have the fixed joint and the two elements that it's been applied to. If this was around the wrong way, then we can use the flip, or we can rotate and offset if we needed to. There are some advanced offsets, which we'll come to later. So we attach this joint to an edge. We could have attached to a face, vertex, or datum objects that have been added to the assembly, or the component itself. Let's hit OK. On the left, in the tree view, we can see we have a fixed joint. I can double click this at any time and edit this joint. Also, if I show it, we can see where the joint is attached. Let's add another component. We can use the task or the component button on the toolbar. Let's add another bracket. The bracket's been added and the widget is available to move it. But as it's not grounded or there's no joint against it, we can click off and move this into position. Let's create another fixed joint. Let's OK the tasks. And we'll swing this around in the 3D view. Now it may be easier to change our navigation preferences for rotation. Let's come up to Edit, Preferences, Expand Display, and look for navigation. In here we have the rotation mode. At the moment mine's set to Windows Center. Let's drop this down and set this to drag at cursor and hit OK. So rather rotating around the Windows Center, we can now rotate around the cursor. So I can say hover over this vertex and rotate around the vertex. And the same with this face. This might make it a lot easier to apply our joints to the assembly. We're going to apply the joint for this one in a slightly different way. Rather than clicking on the fixed joint first, we'll select the edge we want to constrain and then swing around and control select, holding down control on the keyboard, the other edge, and then select fixed joint. Notice the other component has become transparent, and this is because of the isolate. It's set to transparent, and we can alter this to say hidden. So if we have any components in the way, we can temporarily hide those from screen, making it a lot easier to select edges. Let's set that back to transparent. Once we're happy, let's hit OK. Remember to save. Now if you remember earlier, I double clicked on the mirror and I edited that base part. So if we look down to the bottom, we can see the base part, has an asterisk by it, saying it needs saving. We reverted those changes via the undo, so I'm just going to hit no. The assembly is saved, and we have our first assembly. So now we've created our main assembly. Let's create another one, but this time with the sliding bracket instead. We could start a fresh document, but in this case we'll save the current file as a new assembly and replace the brackets within. This approach helps us understand how to safely remove and manage components within an existing assembly. Let's go up to the top menu, File, and Save As. And we'll call this Slide Bracket Assembly. This new assembly can later be imported into our main assembly using the import component. When assembly is brought into a larger assembly, they are referenced as subassemblies. These are useful for grouping components that can be developed and managed independently. For example, in a car design, you wouldn't assemble every part at once. Instead, you would create subassemblies such as the gearbox, suspension, and other systems, and then combine them into the final product, the car. When removing components from the assembly, you need to be especially careful. If we remember back to a previous lesson in this tutorial, a common mistake is to select a component from the 3D view. Say this base. If we look to the left, we see the mirrored is selected. This is the feature. If, say, we deleted that by hitting delete on the keyboard, we're actually deleting a feature rather than the component itself. And this will pass down to the original part, as you can see here. If we hit undo, the feature is back in the original part and also in the component. This happens because assembly components are linked references to the original imported files. As a result, selecting geometry in the 3D view often targets the underlying feature, typically the tip feature in the part design. Deleting at this level affects the source part. To avoid this, it's best to delete from the tree view. So we have our base and we have our bracket, which we can select and hit delete on the keyboard. We can delete from the 3D view. It involves multiple clicks. Let's select the bracket. If we look to the left, we see information about the bracket. And if we expand tree view for the bracket, we see that the face of the pocket is selected and the pocket is highlighted. If we select again, the whole pocket is selected. If we select once more, we see the highlight moves up to the bracket. We know it's in the assembly because it's highlighted in there. And if we look at the data tab, we can see we're picking the linked object. So I can hit delete from the keyboard. We check back to the bracket. We can see we have a bracket in here and everything's fine. Let's return back to the assembly and import the slotted bracket. Now, one tip to make selection easier is that you can enable sync selection. If we go up to the top menu, view, and come down to tree view actions, we have a number of options in here. If I hover over sync selection, we can see it spans the tree item when the corresponding object is selected in the 3D view. If I select that, so it's checked, if we select the base, we can see it spans. This makes it a lot easier when we have a number of items in the tree view. So if I collapse all of these, and let's have a look, say deep into our bracket slot, and this is outside. The minute I select, we select the item in the tree view, and everything is expanded so we can see it. So now we've removed all the components for the assembly, so only that the base remains. We're now going to create a sliding joint with the new bracket. Let's save our assembly, and we won't bother saving the dependencies. To import the component, use the toolbar or the insert component. We can see we have the slotted bracket here. Let's just cancel this. Now, one thing that may happen is if you come back to this assembly and we go File, Close All, and I'm going to discard the changes and we'll load the slide bracket. Activate the assembly by double clicking on it and insert a component. So you can see on the right hand side when we open it up, because we haven't used a bracket, we don't have any components. If the file has multiple components like the bracket, we just place the normal bracket in here. Let's hit OK, and we'll save this, close the document, go back to the slide bracket assembly, make sure the assembly is active, import a component. You'll notice that the bracket here is partially loaded. Because we've only used one component, it's only loaded what it needs to. To fully load the document, we right-click on it and select Fully Load Document. Then we get the other bracket in here. I'm just going to select this bracket, selecting it from the tree view, and hit delete on the keyboard, and we'll import the slotted bracket and position it, let's say around here. We can click off and freely move it just by dragging it. Let's hit OK. Now we have the bracket component in our assembly. We'll be using the slider joint to constrain the bracket to the base. The idea is to allow lateral movement allowing us to virtually simulate this oval hole. There are a number of ways to apply the sliding joint. In the ideal world, we'll have two edges or two faces that run in the same direction. If I wanted to slide this way, I can take the circular edge and control select this edge here and create the sliding joint. This slides this way. You can see the blue axes are aligned, but we want to slide back and forth this way within certain limits. And this is where we have to manipulate these coordinate systems into position. To do this, we'll use the advanced offsets. Let's check the box, and within you'll see offset 1 and offset 2. These relate to the lists. So offset 1 is the first one in the list, offset 2 is the second one in the list. At the moment, the sliding joint is sliding this way. Let's deal with the bracket first. So the bracket slot edge is offset 2. If I select it, I can then change the axis. So we have X, Y, and Z. At the moment, we have a 1 in the Z. So any angle offset will be rotating around that axis of the local coordinate system. So it's orientated this way. These aren't partial values. So for instance, if this was 100, this is still along the Z. It's normalized inside FreeCAD. I need to align the Z in this direction, so we need to rotate around the Y of the local coordinate system. We place 1 on the Y and 0 in the Z. Now let's place some angle. If we add some angle, our component starts to rotate. So let's set this to -90 degrees. Obviously this isn't correct yet. Let's hit OK. And now we draw our attention to the base edge. This is our first offset, this one here. Again, this is along the Z. Let's zero this out and place it along the Y. The idea now is to straighten this back up by adjusting the other coordinate system. So let's change the angle to -90. If we look at the coordinate system, notice the blue Z-axis. It's now running this way. If we hit OK, we've now got lateral movement going back and forth in the direction we need. This would be much easier if we had, say, an edge to align to, which we could use, say, these two edges. But this gives you an idea of how to use the advanced offset. Now we have the minimum and maximum length. These are used for limiting. Let's look from the top and reorientate our 3D view. If I move this component back and forth, watch the fields. They increase and decrease as we move the component. So once those are checked, they will limit lateral movement. Let's move the component so it's just on the edge. So here it's 0 and here it's around about 5. And we can see that by looking at these fields. Now we may get these around the wrong way. The minute we check one and set the length, this one was 0. We go back and make sure we've got the right one. So as you can see, we can't go any further than the edge of that hole now. Let's move this to the left, to the edge of the circle, and we can see we have 5 millimeters. Check the max length. If this was something like 4.99, then we just change that to 5. So now we've isolated the movement of this component. Let's hit OK. Rotate the 3D view, reposition, and we can see that working. Let's create a joint against different geometry. So we need to add the component. We'll have the bracket slot. That's OK. And we'll just select it once and again and manipulate this round to roughly into position. This time, let's use this edge here and this edge. So we can either control select them or make sure nothing's selected and use the slider joint. Add one edge and then add the other. These are in line now. So we have lateral movement that we need. And also I can limit this by setting the min and max value. Place 0 in here to make sure we've got the right one. Let's just bring this way a bit more. So these are going to be different. So this is going to be a minus 2.5. And our max, look from the top, is going to be around about 2.5 as well. This time in the positive range. And click OK. So now we have this constraint down. So the same constraint, just constrained in different ways. We are now going to create a main assembly and import subassemblies and understand how we manage those subassemblies as components in our projects. First of all, let's create a new document and come over to the Assembly Workbench. We'll create a new assembly and then save the document. We'll save this as main assembly. To import a subassembly as a component, it's the same process. We click on the component. If we come over to the right hand side, then we use the open file. Let's select our bracket assembly. Now it's important to remember that the assembly container will be available along with the body parts. So we have the base and the bracket and the assembly. If we name the assembly in our subassembly, then we won't have to rename it when it comes into the tree view. Let's just click on it and add it to the 3D view. Again, you might see the message to ground this part. If you don't, then we can hit OK, place the subassembly, and then ground the component. We now import the sliding bracket using the same method. Let's import the component. One thing that you may see is that when we open the file and import the sliding bracket and hit open, we'll see the assembly has come in. But if we look up the tree, we can see the bracket is partially loaded. We may not have noticed this before, but if we look in the tree view, you can see the bracket slot and the other brackets have got exclamation marks by the side of them. And if we look down to the bottom, we see that the link has not been restored. So if we right click and fully load the document, that should solve those links. But if I don't do that and pull in the slide bracket assembly, because this depends on the bracket, then those components won't be loaded. As we can see here, we just have the base. The base is loaded, the bracket's loaded, but the sliding bracket with the oval holes hasn't. So let's come over to the partially loaded document, right click and fully load the document. Now we haven't got any errors and we can see we fully loaded all the components. Let's just move this out of the way. And we'll hit OK for now. So we have a grounded subassembly that we can unground and move out of the way. And I'm going to create a constraint, a sliding constraint against this assembly and this assembly. We'll just ground this one. Now remember with this assembly that the brackets should slide as well. So if I ground this one and pull on these brackets, they're not moving. Now this is because it's a rigid assembly. FreeCAD is treating an assembly as a completely fixed internal structure. Internal joints still exist, but components inside the subassembly cannot move relative to one another when used in high-level assemblies such as this. Instead, they would have to be manipulated in the original assembly itself. But we can modify this. If we select the assembly, and if we look over to the left, come into this assembly, this is the sliding assembly. Let's just rename this quickly. We select the assembly and look down to general, we have rigid, which we can uncheck. Notice the grounded joint has been removed. So let's select it and add the grounding joint back. Now if I take the bracket, we can see we have movement in there. And the joints are working correctly. I'm just going to take our assembly and unground it. So this is free floating. Let's make a joint, say between this edge of our fixed assembly and control select the other edge and make a sliding joint. When you create the joint, the assembly may move, and because these two assemblies are very similar, they occupy virtually the same space. That's okay on the sliding joint. So somehow we have to move one of these assemblies. If I try to click and hold, as you can see, I've probably selected the grounded assembly, so I can't move it. If you find you're in this predicament, find the assembly on the left-hand side that can be moved, which is the sliding assembly. Look down to the placement, expand the placement, expand the position, and alter the travel on one of the axes. So in this one, it's the y-axis, and we'll just move that. So now we can grab hold of it and move it out of the way. So now we can see the sliding joint in action. And also we should have the sliding this way as well. Remember, we don't have to include just sub-assemblies in our main assembly. We can import other components as well. So that's a basic introduction to the Assembly Workbench, sub-assemblies, and some basic joints. I hope you enjoyed that video and hope to see you in the next one. If you like what you see and you want to donate to the channel, then you can do so via Ko-Fi or Coffee at ko-fi.com/MANG0 or via PayPal at paypal.com/paypalme/DarrenBEstone. I also run a Patreon where you can get early access and additional content, and that's at patreon.com/MangoJellySolutions. Links can be found in the channel header, on the About page, or in the descriptions of these videos. I thank everybody that's donated so far. It really helps to keep the lights on so I can produce more content and also expand the channel. Thank you for liking, commenting and subscribing to these videos, and I hope to see you again in the next one.